Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at LTRI-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Let's review acids and bases as presented in our Chem 106 course. In this course, we use the Bronsted-Lowry definition for acids and bases. Just for your information, there are two other definitions that can be used, Bronsted-Lowry being the most common and the one presented in this course. So under Bronsted-Lowry definition, an acid is a proton donor, whereas a base is a proton acceptor. And if you remember, in this case, proton, hydrogen in its normal state has one proton, it has no neutrons, and it has one electron. And so H plus is without the electron. So all you're left with is your proton. So H plus is a proton, and that's what you're donating from an acid and accepting if you're a base. Now the generic equation shown in your textbook is this first one here. HA, hydrogen with A being an acid, will react with B, a base, and come across here and get, you'll make the acid will lose the hydrogen, become more negative or negative here, charge, and the base will accept the hydrogen. So when you look at this, common to show a representation like this, HA is losing the proton, so it's losing the H plus, and so HA is the acid here, and B down here is accepting, so it's gaining the proton, so it's the base. Another concept they introduce is this term here on the right, conjugate acid-base pairs. And it's essentially what I show here in the arrows. Your acid-base pair, first one I showed was HA and A minus. And one of the reasons they call this a pair, if you notice here in the middle, I show a double arrow. These reactions are reversible, forward and backwards. So if you're moving in the, say to the right, if you're going this way, H is an acid going over to A. If you reverse the reaction, and let me clean this up a bit, it's just getting a little confusing. In the verse, if you reverse the action, A minus here is going to gain H plus, and therefore it's acting as a base over and forming HA, the acid. And so this is called the conjugate base for this conjugate acid. And then again, you have the same thing here between HB and B. And over here on the right, you see that's the other acid-base pair. So that's the generic way that it's represented in your textbook. And I have two examples here to show how that works. First one, we have hydrogen bromide with a fluorine ion reacting and making a bromine ion in hydrogen fluoride compound or molecule. Again, we do our little arrows. If you notice this one, HBr is losing, so it's losing the H plus, and therefore HBr is an acid in this direction going to the right. And then fluorine will be your base. It goes over here and grabs the proton or the hydrogen ion. And then these are your pairs, HBr and Br minus, and your other pairs, HF and F minus. Now, the next example I use is because commonly in your textbook and in normal, say, chemistry, you'll often find water involved. So this example here, hydrogen chloride reacting with water to make chlorine ions in H3O+. So what I wanted to review here, again, the this is your acid, hydrogen chloride, and it's losing or donating the hydrogen. This is its conjugate base. Water here is gaining the H plus. And what is might be new to you is this term H3O plus. That is a hydronium ion, and it's first introduced in this chapter on acid and bases in this course. Water in its natural state actually dissociates in equilibrium, and some of the water will break up into these two ions, the hydrogen ion and the hydroxide ion. And what happens immediately is that hydrogen ion very quickly react with another water and will form the hydronium ion. So overall, when you have just, say, a beaker full of water, you will have an equilibrium here, equation represented this way, going back and forth between water and the hydronium ion and the hydroxide ion. And this shows an important property of water, that it's amphoteric, which means it can act as either an acid or a base. So in this equation here, if you look, let's use this water going to H3O plus. It's gaining an H plus. So this is acting as a base. This water here, if you notice, is losing a hydrogen, H plus, hydrogen ion. And so this is acting as a acid. So water being amphoteric can act either as an acid or a base, and you'll see as you work with acids and bases, water is a very common molecule involved, and it's very versatile because it can work in both as an acid or a base. Now, one further thing I'd like to show here is some of your acid and base conjugate pairs. You'll see a bunch in your textbook. But the way to look at it is, if we look at the acids first, you have hydrogen fluoride. The acids are going to lose an H plus. So its conjugate base here is just going to be the fluorine ion because it loses the hydrogen. The next one here is our carbonic acid. It's going to lose the hydrogen, and you're going to go to HCO3 minus. Which is the bicarbonate ion. And that ion, again, down here on the left, it can further lose another hydrogen and go to CO3 2 minus, which is a carbonate ion. So that's what's happening with your acids to form your conjugate bases. Now, if you start with a base to form your conjugate acid, now you're gaining that hydrogen ion. So here's essentially going to be water. Your hydronium hydroxide ion is going to grab a hydrogen and form water. In this cyanide ion here, you're going to, because it's a base, will accept hydrogen and make HCN, hydrogen cyanide. And here your hydrogen phosphate ion, if you want to call, you add this and you're going to make H3PO4 phosphoric acid or hydrogen phosphate. And so when you have a base, it's going to be adding the hydrogen to form your conjugate acid on the right here. So that's just a kind of a review of what's happening when you look at these conjugate acid-base pairs. Thank you.